this section we will be working with negative exponents. Now the properties of negative exponents are listed in the box at the top of your page, and you need to be able to apply these and work with these for examples like those shown here in example 1. So for part A we have x to the negative third power. Whenever you have a negative exponent, it effectively takes the reciprocal of the base. So here we have x to the negative 3 power. This can be rewritten as 1 over x to the positive 3 power. Here we are applying this rule right here. For part B, we're going to apply this rule. We have 1 over x to the negative 3 power, and our instructions are to rewrite with a positive exponent. So this would be x to the positive 3 power. For part C, we have 2 to the negative 3, and applying again this property, we have 2 to the negative 3 is equal to 1 over 2 cubed. 2 cubed is 8, so one last step here, 1 over 8. For part D, we have a fraction, 4/5 raised to the negative 2 power. What we want to do first here is deal with the negative sign. The negative exponent takes the reciprocal of the base. So this can be rewritten as, instead of 4/5, the reciprocal of that would be 5/4 to the positive 2 power. Now we simply square what is inside. 5 squared is 25. 4 squared is 16. For part E, we have 3x to the negative 4. It's important to notice here that this negative 4 exponent is applied only to the x, not to the 3. The 3 remains untouched, just stays out at the front of the problem. The x is raised to the negative 4 power, so this would be 3 times 1 over x to the 4th. Putting this together, 3 times 1 is 3 over x to the 4th. For part F, this is a little bit different. Here the 3x is inside parentheses. Everything raised to the negative 4 powers. So what we want to do here is first deal with that negative exponent. The negative exponent takes the reciprocal of the base. So I'm just going to rewrite this as 1 over 3x to the positive 4. Once we have that with a positive exponent, now we can just apply the power of a product rule. This would be 3 to the 4th x to the 4th in the denominator. And last step, 3 to the 4th is 81, so this would be 1 over 81x to the 4th. Now example 2, we have some more problems involving properties of negative exponents, and these become a little more complicated. Here for part A, we have p to the negative 4 times p to the 2nd times p. Now one thing you want to remember here, when you don't see an exponent, you can always imagine an exponent of 1. So here we are multiplying. So the multiplication property of exponents tells us to add the exponents. So we have negative 4 plus 2 plus 1 in the exponent. Working that out, this will be p to the negative 1 power. And our instructions say to write only with positive exponents. So we need to take one more step and rewrite this as 1 over p to the 1st power. Part B here, we have 2/3 times a to the 5th times b to the negative 3rd times c squared. Now none of the bases are alike, so we cannot do any combining, but what we need to do is get rid of these negative exponents. So what I'm going to do here, I'm going to start by drawing a fraction bar. What we need to do is decide which of these go in the numerator and which in the denominator. Starting with the fraction is easy. The fraction has already been done for you. The 2 is in the numerator, the 3 goes in the denominator. Now the a here, it's a to the negative 5th power. Because of this negative exponent, the a will go in the denominator to the power of positive 5. And the same is true for this next factor, b to the negative 3. The negative exponent tells you that it will go in the denominator. So we have b cubed in the denominator. Now for c squared, the exponent is already positive, so it is going to stay in the numerator. For part C, we have division, d to the negative 2 divided by d to the negative 7. Now the rule states that when you are dividing, when you have the same base and you're dividing, you subtract the exponents, and that is exactly what we're going to do. So I'm going to write d to the negative 2 minus, I'm going to use parentheses here just to separate out the negative number. So negative 2 minus a negative 7 equals d to the negative 2 minus a negative 7, resolving the signs. So that would be negative 2 plus 7, which is 5. Now part D, this last problem, we've got a lot going on here. We have to basically simplify this expression. And what we've done in the past is compared the numbers with the numbers, in this case the t's with the t's, the u's with the u's. That's exactly what we're going to do here. So I'm just going to start with the fraction, 4/6. I'll reduce that in the next step. T. On the top we have t to the negative 10. In the denominator we have t to the negative 3. The rule states that when we're dividing, we're going to subtract the exponents. That's exactly what we're going to do. So t to the negative 10 minus, again parentheses there just to separate out the negative number. There's the negative 3. Do the same thing with the u. U to the, you have to know there's a 1 there in the numerator, even though it's not written. So u to the 1 minus negative 1. Now in the next step, we're going to simplify all this. 4/6 can reduce down to 2/3. T to the 10 minus a negative 3, again minus a negative, that's the same as adding, gives you negative 7. U to the 1, again resolving the signs, 1 minus a negative 1 is 1 plus 1, or 2. And the last step, instructions say only positive exponents. So again, here's the fraction bar. The fraction itself, 2/3. Now the t to the negative 7 power, because it's negative, it's going to go in the denominator, t to the positive 7. U squared, because the exponent is positive, u squared goes in the numerator.